Welcome to Brain Vision.
In the first part of this problem, we are given that brick is put in the basket and we want to find the maximum stretch in the spring. Here we will use the conservation of energy to find the extension in the spring. According to work energy theorem, initial kinetic energy plus initial gravitational potential energy plus initial elastic potential energy is equal to final kinetic energy plus final gravitational potential energy plus final elastic potential energy. Here we have taken point 1 at the initial position and point 2 at the final position. Here we will assume y equal to 0 at the initial position of brick. So we will have initial gravitational potential energy of brick equal to 0, as we have chosen y1 equal to 0. As at the starting there is no extension in the spring, so we will have initial elastic potential energy also equal to 0. As brick is dropped in the basket, so brick starts from rest. That's why we have initial kinetic energy is equal to 0, and we have final kinetic energy of brick is also equal to 0, as brick comes to rest at a final position. Now we can put all these values in the work energy theorem. So we have initial kinetic energy 0 plus initial gravitational potential energy 0 plus initial elastic potential energy 0, that is equal to initial kinetic energy, that is equal to final kinetic energy, which is also equal to 0, plus final gravitational potential energy, which is equal to mgh. Here m is mass of brick, which is 3.00 kilogram, as mass of basket is negligible, into g, which is 9.8 meter per second square, into height covered by basket. Let this is minus d1 plus final elastic potential energy, which is equal to half into k x square, that is half into k is spring constant having value of 1500 newton per meter, and extension in the spring is equal to the height covered by brick, which is d1, square. By solving this equation, we will get the value of d1, that is d1 equal to 0.04 meter. So this is the distance that spring will stretch. Now in the second part, brick is released from a height of 1 meter above the basket. Now again we will find here the maximum stretch in the spring. Here first we will calculate the speed of brick when it hits the basket by using the relation 2a s is equal to vf square minus vi square. 2a, here a is gravitational acceleration having value of 9.8 meter per second square. S is the distance covered by a brick above the basket, which is 1 meter, equal to Vf, that is the speed of brick when it hits the basket, minus initial velocity of brick. Here the brick starts from rest, so we have initial velocity equal to 0. This gives us Vf square equal to 19.6 meter square per second square. Now we can put different values again in work energy theorem. Again we will take the initial position of basket as y equal to 0. So initial kinetic energy of brick, that is half into mass of brick 3 kilogram into v square, that is square of the speed of brick, which is equal to 19.6 meter square per second square, plus initial gravitational potential energy of brick, which is equal to 0, as we have chosen position of basket as y equal to 0, plus there is no expansion in the spring, so we have initial elastic potential energy of spring also equal to 0, which is equal to final kinetic energy, as at the maximum extension brick comes to rest, so we have final kinetic energy also equal to 0, plus final gravitational potential energy, which is equal to mgh. M is mass of brick, which is 3.00 kilogram. G is 9.8 meter per second square, and here height is let height is d2 minus d2 plus expansion, that is elastic potential energy in spring, which is half kx square. Here k is 1500 Newton per meter into d2 square. This gives us 19.4 is equal to minus 29.4 d2 plus 750 d2. Here I have neglected units to make this equation simple. So this is an equation, this is a quadratic equation in variable d2. We can use quadratic equation to get the value of d2. So by solving this equation we will get d2 equal to 0.22 meter, and the second value is minus 0.18 meter. As in part A we have already found that without the initial Supita brick, extension in the spring was 0.04 meter. So when a brick falls from certain height, then we will get some another extension, and the new extension in the brick will be equal to 0.22 meter. So this is the further extension of 0.18 meter. So here the maximum extension in the string is 0.22 meter. So after the spring stretches to maximum point, it returns back to its equilibrium point, and it will compress to a distance of 0.18 meter. So the maximum stretch in the spring is 0.22 meter.